Hello, in this video we will discuss some additional reactions of aldehyde and ketone. Before that, I would like to review about the Wittig reaction that we discussed in part 1. In Wittig reaction, what happens is, again, this is in part 1 we discuss about Wittig reaction. I would like to review that giving one example. Say for example, suppose we wanted to make the compound containing say cyclohexane ring with the alkene that once on the other side we have, say for example, some butyl group and methyl group with the alkene attached. So this is the structure that we wanted to make. Now since we are creating here carbon carbon double bond, this reaction we can achieve by the Wittig reaction. And we have actually two ways to create this carbon-carbon double bond in Wittig. One, so first you split this into two parts. So the one portion will come from the aldehyde or ketone. The other part will come from the uh, ylyde. So you can use any one part as the carbonyl compound, aldehyde or ketone, and the other part as the ylyde. So in this case, the one possibility would be, suppose we are using the 6-member ring. This is the ring, so this would be a ketone, plus the other part would come from the ylyde, that is with carbon with one methyl group and other one, 2, 3, 4 carbon chain, that is a butyl group, and this will be have to be negative, that needs to be attached with triphenyl phosphine, that will be our ylyde. So this is the way that we can synthesize this compound. And by the way, this ylyde, in order to generate that, what we need, we have methyl group and butyl group, and carbon needs to have hydrogen, and of course it has to have either chloride or bromide as a leaving group that needs to react with triphenyl phosphine, and um, that will do the SN2 reaction. And in the second step, then we have to remove this hydrogen by using butyl lithium. So first of all, we need to react this with the triphenyl phosphine, and then the hydrogen needs to be removed by butyl lithium to generate this ylyde. Okay, so that is one method. Uh, and the other method could be, you can get these while the aldehyde or ketone from this, see, carbon with methyl group and butyl group, and the double bond O, that will come from the ketone, whereas the ylyde will come from the 6-member ring. The 6-member ring that needs to attach with the this triphenyl PPS3 plus, and the carbon needs to be negative. So that is what will be ylyde. Ylyde, and this is the carbonyl compound. Now, where does this ylyde come from? In order to create this ylyde, you need to have a 6-member ring that is attached either with the bromine or chlorine, and their other has to be hydrogen, that then needs to be reacting with triphenyl phosphine, and you need what, a butyl lithium to remove this hydrogen. This hydrogen will remove by butyl lithium, triphenyl phosphine, lone pair of electron will attack there, and then bromine will leave and hydrogen is removed by butyl lithium. This is how we get ylyde. So both ways are possible in order to create this. This is how you need to execute the problem related to the Wittig reaction. So this is what we have discussed in our previous video. Okay, just I wanted to re-emphasize the importance of Wittig reaction in this part. The second reaction that we discuss here is about the what we call is the hydration of hydration of aldehyde and ketone. Okay, hydration of aldehyde and ketone. This is the other reaction. And when aldehyde and ketones, when we say hydration, this is the reaction with water, and that normally takes place in presence of in H plus as the catalyst, acid catalyzed hydration. That is what we normally call. So how does the reaction takes place here is, say for example, we can use a CS3C double bond O, CS3, say acetone. And if you do the hydration, and that normally happens in addition of water in presence of acid, then CS3, CCS3, this will have OS group that will be generated. But this compound is not very stable, and so this reaction would be reversible, more proceeding to the left, like ketone is the stable compound in this case. So how does this mechanism takes place? It's worth knowing the mechanism, so we will discuss that quickly here. Whenever we use the acid catalyst, the first thing that we wanted to do is reacting with this acid catalyst, oxygen quickly grab this hydrogen, and you have CCS3. And again, it can be both for aldehyde and ketone. Be careful with that. So it will be double bond OH with the plus there. Now, since you have the plus charge generated in oxygen with a double bond, then you can easily react with water as a nucleophile that will attack on carbon. Then this will form OH here. CS3, C, CS3. This is now OH. Now, since you have, again, remember that you have added here water with the, now it will generate plus. Now, in this case, it needs to quickly deprotonate. We need to do the deprotonation. Any base can easily grab this proton, and then plus charge will be neutralized. So CS3C, CS3, you have the, in this way, two OS group that will be attached. So this is what we call hydration. Okay. The next reaction is number 3. We can also call the reaction with HCN. And this is when hydrogen cyanide, and the reaction is called cyanohydrine formation. Cyanohydrine formation, or formation of cyanohydrine. So how does this reaction takes place is R C double bond O. It can be H or R prime. It can be both for aldehyde and ketone. Whenever we react with HCN, the result here is hydrogen will be added to oxygen and cyanide group added to the carbon. That is how the result happens. So it will go to single bond. It can be again H or R prime, both aldehyde and ketone, and cyanide is added to the carbon. This is what we call cyanohydrine. Cyanohydrine. And if you wanted to see the mechanism for this reaction, again, it takes place in this usual way here. It can be H or R. And here, HCN, this oxygen grab this hydrogen, and from the hydrogen cyanide, so it will form C. This will be your double bond OH with the plus, and hydrogen or R group depending upon aldehyde or ketone. At the same time, now cyanide with this minus will attack on carbon and will result in this final product with the OH in one carbon, and with the OH, and then there is other CN on the other side here. Okay, so OH and CN are added to this one here. So this is what we call cyanohydrine. So this is the formation of cyanohydrine. Now the next reaction is a very popular reaction, that is number 4. That is formation of formation of imine. And this reaction we call that as the Schiff base condensation. Schiff's base condensation reaction. This reaction actually, this is the reaction with the primary amine RNS2 react with aldehyde or ketone. And be very careful in this one here. C double bond O, either it is H or R prime depending upon aldehyde and ketone. It will react with H2 and R. That is a primary amine. You can put R or R prime or R double prime. So basically what happens is here, water molecule will be removed at H2O. That is why it is called condensation reaction. Normally the reaction takes place in presence of acid catalyst. The result is C. This will be now double bond N with the R prime. You have hydrogen or R prime group, that is depending upon aldehyde and ketone. This is called Schiff base condensation. Now the mechanism of this reaction is very, very important. So that is what we need to know very carefully. And since the reaction takes place in acidic condition, the first step of this mechanism is, it can be both for aldehyde and ketone again. You first of all, we protonate this oxygen with the acid catalyst. That will generate double bond OH. Again, this will be H or R prime depending upon aldehyde or ketone. Since OH has now a double bond, there is a plus. That is when this H2NR prime, that is a primary amine, will act as a nucleophile that will attack on carbon, and OH will get a single bond here. So the result is RCH or R prime. Now here OH, and now you can see this reaction very carefully. The R prime NS2 will be added to this carbon. So this is how you draw nitrogen. It has two hydrogen and of course R prime group. Now since this nitrogen has 1, 2, 3, 4 bond, you must have the positive charge. The next step is, we call that deprotonation. So you can use any base like water to grab this one hydrogen from this, and the plus charge will be neutralized. So R, C, OH, H or R prime depending upon aldehyde or ketone, and you have N, H and R prime. Now we got to remove this OH group as water and will create the double bond to get the imine. So since this is the acidic condition, OH will be protonated to make water as a living group. So this lone pair of electron will grab the hydrogen. You have R, C, H. This become now OH2 as a plus, and this, it can be H or R prime depending upon aldehyde or ketone, N, H and R prime. Now you see here you have water as a living group and with the plus charge there. So the lone pair of electron from nitrogen will make the double bond with the water molecule being removed. Then the result here is R, C, it can be H or R prime with a double bond N, R prime, and you have your H. Now nitrogen has 4 bond, so it will be again positive. Now you can easily get rid of this proton, deprotonate, by using any base like water that will grab this proton and the plus charge is neutralized. So that is how we get our imine. This is what we call Schiff base condensation. And this reaction is very, very popular reaction. So it works for, say for example, if you have any aldehyde or ketone, say for example double bond. So it is a, so it's a double bond O, not writing here. Okay, we will stop here and we will continue this in the next video. The pain is